¡Es Ingenium Team!
You are going to see that Picasso, apart from being a great artist, was also a thinker. And he was right when he said that inspiration exists, but it has to find your work. Follow this ball because it has a great story to tell.
Water is a scarce and basic need. According to the Food and Agriculture Organization, about 70% of world's fresh water is used by the agricultural sector. Without water, there are no crops, but excessive irrigation can cause 1. Wasting natural resources. 2. On farmland circle, ground the roots, loss of water percolation, soil erosion, and loss of nutrients for crops. And 3. Environmental consequences, change the composition of microorganisms in wetlands and contamination of water for human consumption. The target is to optimize irrigation.
Now is innovation time.
Experts agree soil moisture monitoring is key to optimal water management. Here we have a table which contains pros and cons of the current humidity sensors. These humidity sensors reduce up to 40% of the water consumption, but their usage is not widespread. Our proposal has two essential parts: a device made up of a ceramic spherical safe case which contains the two main sensors, the electronics and the battery, and the telecommunication system which shows how the information is sent through the gateway to the remote platform on the cloud.
As you can see, on this table, our innovation has clear advantages.
Could you bring it closer? Thank you, thank you.
In this table, a dual sensor display increases reliability of water, reliability of the readings. Current sensors informs about availability of water for the plant, about humidity of the soil, whereas ours tells us about availability of water for the plant. It also informs about the soil types.
The spherical shape simplifies its placement. It's adaptable and efficient in different types of soil, ground irregularities, and different types of crops. It's wireless, it has low-cost materials, and it's unique. There's nothing like it on the market.
We name it the HYDROBALL. I inspired them. It was very important to be quality to the process.
Here's our design process. First, we molded and baked the ceramic clay. The next step was to join the electronic components of the sensors to the motherboard. We made a simple programming Arduino that sends a long-range signal with low consumption from the ball to a server located on the cloud that displays the information through graphics to our mobile devices.
All of this development process is based on a continuous improvement system through an iteration process. We have built up to 3 series of 7 HYDROBALLs, reaching an amazing working prototype. All these changes have been documented in the Engineering Change Notice log.
What a beautiful job! Time to evaluate and verify step by step.
We paired the HYDROBALLs in vermiculite, perlite, and peat to test them and compare them with the current sensors. The experiment was awesome. Accurate and reliable measurements and the ability to differentiate soil types were confirmed.
Now it's time to conquer the world.
The HYDROBALL has been already chosen by various associations and institutions. Some examples are Floret, which is a pre-packed vegetables company, Cooperativa Artajona, and Pago la Reinza, which is a wine producer, for their agricultural operations, as well as the Public University of Navarra and the Institute of Agrobiotechnology, also from Navarra, for research purposes, especially for a European Institute of Innovation and Technology food project for precise agriculture. Also, Vodafone, together with Terrae, which is a group from the Public University of Navarra, for developing a cloud infrastructure for the automation of agricultural processes.
With the HYDROBALL, the era of 1.0 agriculture has begun.
At this point in time, with the patent already presented, we're working on engineering changes directed to large-scale sales production.
Some of these changes are already in development.
Unlike the current sensors, which can cost up to $150, our goal is to reduce production costs to below $20, including the data transmission system.
It is a great market opportunity. Only 10% of the farmlands are currently being monitored. Our HYDROBALL could be extended to small and large-scale farmers, domestic users, as well as ornamental and recreational gardening.
As we have stated on our value proposition canvas, for the farmer, it will be the best investment of his life. For the domestic user, a great solution with which to enjoy his garden.
Picasso was right. Inspiration found them working, and look what they were able to create.
Thank you.
Thank you.
Yeah. Can we open it up?
Yeah, absolutely.
You just have to take it.
Just the rubber band move?
Yeah.
All right.
And then you can see the inside. There's,
Oh, wow. Okay.
this is the battery.
Yep.
Here's all the electronics. The two sensors, this one
Uh-huh.
is the outer one, which measures humidity.
Okay.
And these two nails inside measure the quantity of water available for the plant.
Did you put like a? Is
A
that's,
resin?
Yeah,
that's
yeah.
a resin? Ah.
That's, well, two purposes. First of all, we don't want a lithium battery breaking and contaminating the. And second is to protect the motherboard from moisture and humidity.
Okay. Was that in your original design, or like where'd your original design start?
So we started with a ceramic bowl, but it had like spikes all around. So
Uh-huh.
instead of having two brass bands here, they were like sticking out.
Ah.
But then the idea of getting them round the ball was great. It was a way to simplify the ball's placing,
because
and
it's just like
we got
it's-
inspired by
it's
the
on,
actual sensors.
reads,
Okay.
sends information,
Ah,
then
I try to let
off.
them focus on one
Yeah.
question.
It's just off for 15 minutes and then it's just back on. So that way we can preserve energy as long as we can. That would make
So
it.
what are the lights? What are what are
So,
the lights telling?
As this is a prototype, we
Mm.
send a signal every 5 seconds.
Okay.
So every time
Awesome.
the lights turn on, that means that
A signal is being
yeah.
sent out.
And how deep does it go before you lose signal?
On the roots depth, because you want to know
Oh, we just wanted
what
the root
root.
stuff.
Well,
That makes
what
sense.
you said right now is actually one of the biggest challenges that we have right now, because this has never been done before. A wireless sensor that goes underground, so we
Right.
still have the doubt of if it's going to be able to communicate.
Hmm.
But we are already thinking on some solutions. There is a system called a grid, where the HYDROBALLs talk to each other, right? And then they also talk to the gateway, but the gateways also talk to each other. So in this way, everything is connected.
So what's the success of depth now? Like, have you gotten it down there at all yet to test it, to see if it can communicate? Like, how far down has it gone so far?
In your pots, right?
Yeah. In the pots?
Yeah, we've tested in 3 types of soils. Where is it? There. We've got pictures. So here I've got 2 of them, vermiculite and peat. So vermiculite is very sandy soil, so it doesn't retain water. So both humidity sensors, the one from the market and the HYDROBALL, gave similar results as the internal one, which measures the quantity of water available for the plant. But in peat, which retains water, again, humidity sensors give high levels, but the second sensor's levels fall. That's the difference between a HYDROBALL and the actual sensors.
So what about depth? For instance, when you tested it in sand, how deep did you put it? How deep was it?
It was in the surface because we don't have yet the LoRa system to try it, because in the final product, well, this has a Wi-Fi chip that you can see there, but in the final product we will use LoRa, which is another system for telecommunications, but we don't have it yet, so we haven't tried that yet.
Okay, so this you put it on the surface of the soil
No, for the experiment.
for the experiment.
Yeah.
Okay.
So it's not underground yet? Okay.
So you can see here the data that we get. So if I put this wet towel here,
In a few seconds, the graphs will rise.
They will fall, I'm sure.
This one will rise.
So which graph are we looking at?
Hasn't changed yet.
The soil humidity, because this one has these 2 nails.
Okay, so
but
it's sending now.
yeah, so it's in a few seconds it will. Yep.
So how did while
Could we
they're
add
waiting,
more water?
while they're waiting for the graph, how did you guys come up with the problem? Like what inspired you to look at this problem?
So we first we investigated the human cycle. So what we came across was that 70% of the water that we use is used for agriculture. So we decided that if we focused on that sector, would have a greater impact. So then we talked with some agricultural engineers from the Public University of Navarra, and they were like specialized on sensors. So they told us this experiment.
Well, they told us to look it up.
Yeah.
Okay.
So there's 3 farmers. The first farmer waters his plants on what he thinks. So he wastes 130% of water. The second one uses agroclimatic stations, which are
by the data that from the water that was last week, they build up like what if it's gonna rain or not.
So there wasn't like a personal tie to the problem. It was just as you guys looked at the problem presented by first, you started narrowing it down from there. You thought, okay, what's the biggest usage of water, and then you tried to.
There is also the point that we live on the north of Spain, and it has a lot of agriculture. Like you see everywhere there are crops and fields. So there's probably some influence from there too.
Okay.
And as well, there's one big important problem that one time there was like one from the river. I mean, from the water from the crops, as it carried away the nutrients, right, for the plants. It carried away to the Black Sea, right? I thought it was. Or
no, to the Minor Sea.
Minor Sea, yes. And it wiped out all aerobic life because of the microorganisms and all that.
Okay. And what led to the clay?
Well, so the clay works both as a case, but it's also part of the sensor itself. So let me open it and let me open this one, don't worry. Because that one's the one that's working right now. So you can see that inside there are two other sensors. The sensor, they are nails that are inside the clay. So the clay pulls the water inside, it absorbs the water.
Absorbs it.
Exactly. But the soil on the other side also it's pulling away the water at the same time. So knowing the humidity of the water, the humidity of the soil, and knowing the tension with which the soil is pulling the water away, we learn how much water is available for the plant. So that's
I thought clay was the opposite, that you can't, that it doesn't absorb water.
Yeah, so firstly we baked it at 900 degrees Celsius, but it lost its porosity. So we baked it at 800 degrees, not less, because then it would be
too soft.
Yeah.
Too soft.
Okay.
Yeah, and we got the idea of the clay from these sensors, which are right now on the market, which are these ones. They are called water mask. Yeah. And so these have clay inside of them, and it works like the clay.
It's actually
in
silica
ours.
sand. Because that's why it's like, more expensive.
Okay.
Like that.
All right.
Okay.
Oh, you're fine.
Yeah.
Here you can see it went up.
Oh, it went up. There you go. There you go.
Moisture.
Yeah, we are actually using ThinkSpeak, which is a website for IoTs, but we are developing another for give it to the market.
So you guys have done the code development yourself on the application?
We
develop it?
No, it's software engineers have done it. Are doing it right now for us. Yeah.
So you described for them what you wanted and what you needed, and they've helped write it.
The thing is that we don't want to stop here, obviously. But actually, let me show you. But we have here the patent of the HYDROBALL. We presented it like a few days ago in the government of Spain. And so yeah, we have. Let me show you. These are all the changes that we have right now. That we have planned for the future. The cloud infrastructure is developing right now, and there is a team of software engineering developing it. Then we also make other changes, as for example, now it's full of cables, and the motherboard is 2 squares. So we plan to introduce a circular motherboard without any cables, where the sensors come right out of the motherboard. So in this way, it's all simplified.
So like an ASIC, right? Yeah.
We are waiting for a grant of the government of Navarra, our region, of 200,000 euros.
Wow.
We're going to put ourselves, or the company that sponsors us, the other 70,000, because that's the R+D. It's going to cost 270,000 euros. Just the R+D. Then we have to invest more.
Yeah, here you can see all the data that we have for the, well, this is the market study for 5 years. So we took the statistics from Spain, from the National Institute of Statistics, and we estimated that we would sell, well, here you can see how many hectares are in Spain.
Yeah.
So we estimated that we could sell the HYDROBALL to 15% of the market, and then we did all of this study, as you can see. And we have a profit of 52%.
So
How long have you guys been together?
3 years.
I mean, people have come,
Yeah.
been coming up.
Yeah, but this is our 4th year.
Yeah.
The veterans are 4 years.
So does the app that you guys have them working on for you, does it tell the user like when they should water? Like
That depends on what the user chooses.
Also, in the future, we can program automatic irrigation for like our customers. It's not only the farmers. We can sell the ball in 2 types of market: the domestic users, the agricultural farmers, and also our researchers that investigate in agro.
So we could provide like services, not only the one of these, or the service.
Yeah, exactly. Each customer has its own needs and its own wants. For example, a big farmer wants his plants big, and governmental wants his plants beauty.
And also to take care of the environment.
Yes, you can see that we have developed the value propositional canvas, in which we have done the needs of more or less each customer, the wants, their fears, and you can see that is that, and if you turn around, you can see how we fix that, the features of our HYDROBALL, the benefits and the experiences each one will have. For example,
the customer could, to answer your question, the customer could program it on the app if he wants to irrigate, if he wants to plant, water the plants, depending on the readings from the HYDROBALL, so or if he wants to do it manually or stuff like that. Yeah.
That could also take into account the weather forecast, so if it's going to rain in an hour, you're not going to water your plants.
Yeah, that's cool.
all right,
Great,
well,
great.
our time's done. So is there anything else that you guys wish that we would have?
There is a
got
really
to?
important thing that we didn't say. We're to the farmers, to the big farmers that have hundreds of hectares of crops. We're not only providing them with the ball, but it's also like a service, right? That gives them the security, not only the accuracy of the ball, but also the security that his or her plants, their HYDROBALLs are safe or secure, and to put them underground, take them when the season is over, put them on next year.
Yeah, so the farmer wouldn't have to do anything.
Okay.
So typically, you know, if you have a big farm, how many of those would you have to buy, or you just need one, and you just move it from one space to the other?
No, if your crop is perfect, like all the ground is leveled, you would need 1 ball per 40 hectares. But if it's like irregular and stuff like that, we estimated that you would need 1 ball per 10 hectares. But it depends on various factors. So it depends in the orography, I think it's right. So if you have a mountain in the middle of your field, you will have to put more balls so you know how much water is in here, how much is in here, right?
Yeah.
Also depends on the type of the soil and of the type of crops that you have. So if you have 2 different types of crops, you need some balls for one crop, some balls for the other crop.
I also wanted to say that with the HYDROBALL, we bring precision and sophistication from industry to agriculture. So this is agriculture 4.0.
And the human needs water, and the HYDROBALL saves it.
HYDROBALL will be everywhere.
we even have a commercial.
Oh.
Yeah, so the HYDROBALL has a very high profit margin, so everyone who invests in it will get highly benefit.
We want the HYDROBALL in your houses.
If Picasso had known this ball, he would have painted espresso instead of cubism.
All
In
right.
only months of development, it has awakened so many interests that it's clear that it's going to have a great future.
And this is the future, and you can take part on it.
Great. Thank you.
Great.
Thank you.
Thank you.
Thank you.
Rawr, what are your plans? Rawr, use the hydroball.
Okay.
Well, thank you very much.
Thank you.
Guys.